Hi everyone, welcome back to a new video. And this video is going to be very informative and as well as useful. So I request you guys to watch it till end because in this video we're going to discuss about the network commands for Windows machines. As a network engineer, we learn about Cisco devices CLI, right? We work on other vendor CLI as well, like Juniper, Palo Alto, Checkpoint, and all. But now, as we work in the real-time network and we have to troubleshoot a problems as a network engineer, right? So sometimes we have to deal with the Windows machine as well, or we can use these commands to check the status of the Windows machine that we don't have any problem on that side. So these commands are going to be very useful as a network engineer. So let's start with the first one or the very basic command, which is ipconfig. So let's open the command line, cmd of Windows machine. If I run this command here, ipconfig, you notice that in this output, we have Ethernet adapter to their IP address, subnet mask, IP address, subnet mask. And on my Wi-Fi adapter also, I have an IP address 192.168.31.234, subnet mask 255.255.255.0, and this is the default gateway. But you notice that we are not seeing all the details, like how the IP address is configured, DHCP or static IP, then what is the IP address of the DNS. So we have one more alternative of this command, which is ipconfig all. So if you run this command ipconfig all, you notice the output now. If we go back to the Wi-Fi adapter here, this is my Wi-Fi adapter. So now you can notice that first of all DHCP is enabled. We can see the MAC address as well. If you just run ipconfig command, the MAC address is not visible. But in ipconfig all, we can see the MAC address of the interface. DHCP is enabled. You can see the IPv4, subnet mask, lease time, default gateway IP address, as well as DHCP server IP address, right? And then we have DNS server, which is 192.168.31.1. So in this case, we see more details related to the interfaces and their configurations. After that, we have a very famous command, all of you guys know, right? Ping, which is very useful to check connectivity. I can say ping, let's say www.google.com. So I can ping with the domain name, but please make sure that DNS is configured. So when I ping www.google.com, I got a response, and then the response we see an IPv4, IPv6 address, right? I can also ping my DNS server, let's say 8.8.8. This is the global DNS. So it's also reachable. So we can ping 8.8.8 or we can ping the domain name also. Here, by default, if you notice, Windows machine sends 4 packets. As compared to Cisco routers, they send by default 5 messages. But here 4 messages are being sent. But if I want to send continuous pings, I can say ping 8.8.8 and T. So it will be sending packets continuously. If you want to stop this, you have to say Control C. Otherwise, it will keep sending those packets. And in this output, we can see the time, approximate round trip time in milliseconds. Round trip means that from your Windows machine, traffic went to the server and then get a response. How much time taken? 12 milliseconds. So the average is 8 milliseconds of round trip time in this output. So we can ping 8.8.8 and you can send continuous packets. Until you want to stop it, it will keep sending those messages. Then in our networking devices like Cisco routers and switches, we use a traceroute command to track the path. Let's say if you have a topology, let's say this is R1, this is R2, this is R3, and this is R4. There's a host connected on this side and there's a host connected on this side. If I want to see the path taken by this host or for a packet received on this router, R1 can send this packet to R2, R2 can send this packet to R3, and then R3 will send this packet to the destination. Or this packet can take the other way around as well. It can go via R4, R3. So using the traceroute command, this command will work on this router, let's say. If you want to check the traceroute from a Windows machine, then the command is not traceroute. The command is traceroute. The command is traceroute. So in this CLI, I can say traceroute 8.8.8. Let's say I want to traceroute this DNS server IP address. So first of all, I'm using Geo Wi-Fi. So Geo Fiber dot local dot HTML. First of all, traffic is going to my default gateway. Then there's a next to 192.0.0.1. So it will keep showing us the hops. Let's wait for the output to be completed here. Number of hops you can see 1, 2, 3, 4, 5, 6, 7, 8, right? So we can see the whole path. In this case, when you start troubleshooting, let's say if a host is not able to reach the internet. So first thing you will verify is that you'll do the trace route. And you'll notice that, okay, traffic is going to this router, traffic is going towards the Wi-Fi also. So you know that, okay, from this point to this point, we don't have any problems. So this trace route will help us to find it out that, okay, from this point to this point, there's no problem if the packet is going to that particular device. So you see that this is taking a long time to just trace route the 8.8.8, right? Likewise, you can also trace route a domain name as well as any other IP address using this traceroute command. Using this traceroute command. Then we have a command nslookup. Now when you say ping and you put a domain name www.google.com, it will automatically send a DNS request in the background to resolve the IP address for that domain name. We can check it without sending the ping packets. You see that trace route is complete and it took 15 hops. So now I'll say nslookup. I just want to see the IP address of netflix.com. So the nslookup will do what? It will show us the IP address is resolved by DNS server. So when you say www.netflix.com, it got the IP address 44.237.234.25, 44.234.232.238, and as well as an IPv6 address. But let me show you one thing, guys. You can't ping www.netflix.com. Okay, now it's great. Otherwise, I've checked it multiple times and it doesn't work because they have blocked the ICMP traffic. But I'm happy to see this, that it's working this time. We sent 4 packets and we received 4 responses. So it means 100% success rate and it's working. Then net state. So as we learn in CCNA or in TCP IP model, we have a total, 7 layers, right? We have application layer or presentation layer. You can also compare it to TCP IP model. Then we have transport layer, network layer, data link and physical layer. Data link and physical layer. So at the transport layer, we have 2 protocols, TCP and UDP. As you know that TCP is a reliable protocol. So first thing TCP do is TCP build a 3-way handshake. It means TCP build a connection with the remote endpoint, and after that the actual data transmission will start. So when you want to see that how many TCP connections a machine has built right now, so we can see it with the net state command, this command, net state, and you can also see the port numbers. So if I put the command here, net state, or we can make it fast, you can say net state AN. So it will show you the list of the port numbers opened and established. You see that TCP connection established. TCP connection established with 443. It means that HTTPS connection is there. Then we have port number 443 because of HTTPS connection is established. So it will show us the port numbers and the number of connections here, TCP, UDP, and which port numbers are free to use at the moment or which port numbers are opened on this machine. Using this command, net state command you can run, but you can also run AN command. It will show us it very fast and more detailed output. This command can be very useful for us to troubleshoot the network. ARP, address resolution protocol. ARP is very important on Ethernet media, because what ARP do, guys, ARP resolve MAC address for a given IP address. Let's say if you want to ping any IP address, so you have to encapsulate source IP, destination IP, source MAC, destination MAC. But the destination MAC is unknown for a machine by default. So the machine will send an ARP request in the background. You can check it using this ARP-A command. This command will show us the ARP table of this router. ARP table of this host, not router. And you notice for 192.168.233.255, this is the IP subnet we have on the interface. So it is bind with a broadcast MAC address, because this is the broadcast IP for my IP subnet. Then we have multicast IPs also. For those we have MAC address. These are the static MAC addresses. But I have a default gateway 192.168.31.1. So whenever I reach to a different network, the ARP request is sent for the default gateway. So the MAC address of my Wi-Fi router, and the type is dynamic. Type is dynamic. Then you have a global broadcast IP also, and the MAC address for this global broadcast IP is 12 time F. Let's say our machine is sending a DHCP discover message. So as we know that when the DHCP discover message is sent by a machine, first of all, the DHCP discover will be given to UDP at layer 4. 68 is the source port, 67 is the destination. Then a source IP will be added. So in this, we don't have the IP address. That's why we are sending the DHCP discover. And destination IP will be 255.255.255.255. Then source MAC of the exit interface. Let's say if you're using the LAN adapter or Wi-Fi adapter, but the destination MAC will be FF. And for this, we already have a binding in our ARP table. If you want to delete this ARP table, it's possible. You can say ARP-D. The ARP entries failed, the request operation require elevation. So you have to go to the administration access. If I say CMD, run as administrator, ARP-A, and then we can say ARP-D. Okay, the parameter is incorrect. Again, it's not allowing us to delete this table, but this is the command to delete ARP-A. Using this command, we can delete the ARP table as well. We can delete the ARP table as well. This command is also very useful here. After that, we have route command. So by default, as you know that our routers and our layer 3 devices maintains a routing table. Likewise, the network machines like window machines is also having the routing table. The window machine is also having a routing table. And you can also update the routing table if you want. So if we go to the command line interface again, and we say route. You see, we have the options right here. So route print. In the route print output, you see the routing table of this router. Sorry, this host. Again, I'm saying router. I'm sorry for that. So there's a default route towards the default gateway. So for any unknown IP address, the host will send traffic to the default gateway itself. For the local IP, for 192.168.31.0, there's an IP subnet. Right now, you notice that I have multiple IP subnet on my desktop, because I'm using virtualization. So we have Ethernet adapter, Ethernet 3. So these are two virtual adapters, VMware adapters. And this one is my Wi-Fi adapter. So we see multiple route entries in the routing table. And this is also showing us IPv6 routing table. Even the IPv6 routing table is also visible here. Then if you want to add a static route, you can say route add. And after this, we can add the subnet. After this, we can add the subnet if you want to add any static route in the routing table of this Windows machine. In the routing table of this Windows machine, you can also add a static route. Telnet. In most of the Windows machines, they were not allowing us to enter this telnet command, but now they have started giving the support of this. Let's say telnet 10.1.1.1. This 10.1.1 don't exist at the moment, but I just want to show you that talent command also works on Windows machine, so that we can access a remote device from this Windows PC. You don't even need putty, right? But thing is that, again, we are more familiar with putty and we work with the putty most of the time. And it knows that talent use port number 23. So it is trying to build a connection, but at the moment connection is not built or connection is not working because this 10.1.1 IP does not exist. This telnet 10.1.1 IP does not exist at the moment. That's why the connection is failed or could not open connection to the host. All right. Then we have the next command, which is net sh. Here we have a command, net sh command, right? So net sh command will do what? It will show us, it will show us the IP configuration of the interfaces. Let's say I can say here, if I just put net sh, you enter in that domain, right? And if we put any wrong command, the following command was not found as K. So we have commands here. You go back and you can say net sh interface IP show config. Net sh interface IP show config. This will show us the configuration of the interfaces. Just the configuration, right? Yes, DHCP is enabled on this interface also. DHCP is enabled, not enabled on local area connection 2. DHCP is not enabled on this interface, but DHCP is enabled on Wi-Fi. DHCP is enabled on Wi-Fi adapter. DHCP is supported on Wi-Fi adapter also. It is configured. After that, we have path ping command. So you might have used ping command, but you might not have used this path ping command. This path ping command do what? You will notice here, it will combine traceroute plus ping. So if we'll say path ping www.google.com. So it will combine the ping as well as the path. It means the traceroute plus ping. So it will show us the IP address. It is trying to ping the Google server, and Google server is reachable. Google server is reachable, as well as it will show us maximum hops 30. So path ping will do what? Path ping command will combine the functionalities of path ping command will combine the functionalities of traceroute as well as the ping process. The path ping command can also be very useful in our networks. Just to see the output, you don't have to do separately, like you'll do the traceroute and then you'll say the ping. You can simply say path ping. So it will start this process, and traceroute and ping will work together in this case. So these are the very important commands we have in our Windows, and they are very helpful for a network engineer. They're very helpful for a network engineer in the troubleshooting process. So you might learn, or you must learn, all these commands, guys. All right, sorry, I got a call. So these are the commands we have on Windows machine. You must learn. So yeah, guys, that's all for this video. I hope you enjoyed this, and please subscribe our YouTube channel, as well as you can like the video and share more commands in the comment box. If you know any specific command about the Windows machine for the network engineers, you can put it in the chat comment section. Thank you for watching this video, and let's see next one, okay, which is going to be a very important video on our YouTube channel. So please stay tuned, stay connected. Bye bye, have a good day ahead.